Afternoon. We are going to start the lecture today about extrusion technology. I think others will join. So, extrusion technology is very important. We have discussed general things in the previous three lectures. So, I hope that you are aware about extruders and extruded food products. So, why extrusion technology is important, we have discussed because the extruded food products are cheap in cost, but and also they are very popular among all age categories because we are going to buy extruded food products and children and our grandfather or our father and ladies and gentlemen, girls and boys, all age categories, they like to consume, eat, and enjoy extruded food products. And there are some ready to cook extruded food products are available, and ready to eat extruded food products are also available in the market. But the problem is the nutritional value. Most of the extruded products have been developed using starch and flour-based materials, and some meat-based products are also commonly available in the market. So if we can do something new by incorporating more nutritional value, so I think we will have a good market. And it's very difficult to feed small children, infants. So we can come up with some good extruded food products with highest nutrition value, such as a breakfast cereal. So I hope that we can have a very good market. So the objective of this lecture series is to motivate you to do something new. You can design new extruders, and you can develop your own extruders and some products as well. And we have some underutilized materials in Sri Lanka. As an example, jack seeds and some sort of fruits and vegetables, and some crops also available. So you can use these things to develop new food products. Last week, we have discussed about the extruded die parts. What is the extruded die? Why is it important? And its characteristics also discussed. And single screw extruders. Most commonly, we are using single screw extruders in the food industry. And there are different other types of extruders are available. And we are using such extruders in the polymer and rubber industries as well. And dough forming. What is the dough? It's just a mixture of type of flour and water, maybe, and sometimes some meat mixtures also available. So dough is generally the mixture which we are going to feed to the extruder. And some extruders, we have preconditioning systems. So in the extruders with preconditioning systems, we need not to prepare the dough, and but we need to put the raw materials to the extruder, then the extruder will prepare the dough itself, right? And Newtonian and non-Newtonian fluids also discussed, and the assignment one also discussed. So you have to upload your assignments to the LMS. Okay, then today we are going to discuss some engineering parts relevant to the extruders. So in the folder I have uploaded to the LMS is not contain all these details, because every week I monitored that there are only 15-20 people they are joining with the lectures. So I have uploaded the presentation without some details. So video also I will edit the video and upload, because the others, if they have problem, I don't have any problem. I can forget these things, but every day I can see there are only 10 to 15 people. So we are doing lectures, we are reading books, and we are motivating you to do new things, but I'm not sure whether it is a joke or not. Okay, so then they can learn these things from anywhere. any institution, so no matter. So we can go ahead. But I think you guys are joining with the lecture every day, so no problem, right? So I'm not going to explain these things again. So I will explain today in detail. If you have question, you can ask after raise your hand. Then you, in this Zoom, you have a raise hand option. So please raise hand and ask your question and get the things clarified. Okay, then I think we have discussed this thing, this graph last week. So you know the die is there, right? In this end, we have a die. When we close the die, the pressure is very high, right? When we close this die, you know the pressure is very high. But when we open this die, the pressure is very low. In this graph, you can see that when die is open, the pressure is Q is max. Q maximum. Q means the output, kilograms per hour. Then open the die means the output is maximum and the pressure is minimum. When we close the die, then output is zero, but the pressure is maximum, right? So we are going to operate the extruder by addressing these pressure limits. So this is the operating point. It is actually we can change the operating point based on our product and the requirements. So this is just an example. So you can see when we open the die, the pressure is very low, but the maximum output is there. And when we close the die, pressure is very high, output is zero. So we have to study the graph for the particular extruder, and based on our requirement, then we can draw this graph, right? So the net flow rate is very important. Net flow rate means, you can see here, the net flow rate relevant to the point, right? We need this net flow rate, right? So we have decided the pressure and also the die shape, everything we have determined, and then we are going to start the process. And before that, we have to calculate the net flow rate. It is based on the drag flow and pressure flow. So what is the drag flow and pressure flow? I suppose you can remember these things, pressure flow and drag flow. What is the meaning of drag flow and solid bed? I have discussed these things with you in the last previous lectures. So drag flow means, in this picture you can see the drag flow. When we switch on the extruder and mix the raw materials, then what happens? The extruder starts to carrying the raw materials from the feeder to the die end, right? It means when we switch on the extruder and start the raw materials, start the feeding, then initially as a result of the flights and the shape of this what we call the shaft, then it will start to drag the raw materials from feeding side to the die side. And with the time, you can see the entire barrel will fill. The entire barrel completed the dough. It means bed, solid bed. But initially we have drag flow, right? Here you can see drag flow from the feeder to the die side, right? Then as a result of this drag flow, now we have raw materials here, then it will start the pressure flow from the opposite side, right? We can අපි දැන් extrude එක switch on කරාම මුලින්ම මේක extrude එක start වෙලා raw material ටික ඇදගෙන යනවා මේ extrude එක move වෙන නිසා die එක පැත්තට right එතකොට ටික වෙලාවක් යනකොට die එක පැත්තේ raw materials එනවා එතකොට අපි කියනවා මේක පිරුණාම bed solid bed එකක් කියලා එතකොට මොකද වෙන්නේ මෙතන තියෙන මේ solid bed එකේ මේ die එක පැත්තේ තියෙන door එක නිසා අනිත් පැත්තට pressure එකක් ඇති right I think it's clear so the net flow rate means drag flow minus pressure flow so drag flow is there and pressure flow is there the difference of these two flows we consider the net flow rate but in some cases this is a practical situation in this picture you can see output equals to drag flow minus pressure flow plus leakage flow output equals drag flow minus pressure flow plus leakage flow there is a new term called leakage flow right leakage flow is there due to what you can see there is a space very small space within the barrel and the shaft right in this end you can see the very small space as a result of this pressure flow you know the pressure flow is very high pressure so the raw materials will move through these ends right through these small spaces the raw material will move we call it as leakage flow right so as a result of that the output equals in the practical situation drag flow minus pressure flow plus leakage flow I think it's clear now right basically we call it as drag flow minus pressure flow but in the industrial level and practical situation there is a leakage flow so we have to count it as well right then what happened when we increase the restriction level means resistance right when we increase the resistance it means the shape of the die right we can use a die with a very small hole with the die shape you know the pressure will deviate pressure will change so when we increase the restriction level it means the resistance against the door then pressure will what happened to the pressure any idea how the extruder is working and we are going to change the die shape then you know resistance will change right as a result of this resistance what happened to the pressure flow
It will increase.
what happened to the pressure flow
Increase.
Or decrease
Increase.
yes it will increase then what happened to the pressure so then what happened to the net flow increase or decrease
Decrease.
so those things are very important in extrusion so you need to understand these things so when we change the die shape the pressure flow will increase as a result of that the net flow will decrease because the drag flow is a constant the drag flow is will not be changed so therefore when we change the die with small holes it means the resistance is high and parallelly pressure flow is also high then net flow will decrease right okay and then the channel depth what happened when we increase the channel depth it means deeper screw channel depth any idea මේ channel depth එක වැඩි කරොත් මොකක්ද වෙන්නේ?
Pressure is decreased by
Pressure decrease.
yes, sir.
Then what happens to the net flow? Any idea about the net flow? When we increase the channel depth, it means deeper screw channels, then pressure flow will again increase and net flow will decrease. Right? So, therefore, we need to consider about the channel depth before purchasing an extruder, right? All these things are very important. Flight width, everything, these things are very important. So, technology students, you should have a very good knowledge, right? Technical knowledge before purchasing. So you have technical knowledge. So in your curriculum, these things are not available, but I think these are the important things. If not, I can download so many theories regarding the extruders. It's so easy to explain you, but when you go to the industry, then what happened? Then somebody will ask, what happened when we change this shaft? So you have to find answers. So therefore, these points are very important. When we increase the channel depth, then pressure will also increase, pressure flow will also increase. As a result of that, net flow will decrease. Therefore, if we need to get the higher output, then we have to select a screw with shallow channel depth. Got it? Okay. And normally we can see grooved barrels. You know, a screw is inside the barrel. There are grooved barrels. In so many extruders, almost all the extruders, we can see grooved barrels. Why is that? Here I explain output is equal drag flow minus pressure flow plus leakage flow. There is a leakage flow in this type of barrels. So what happened when we introduce a grooved barrels? Then we can decrease the call it as leakage flow, and also we can increase the efficiency of the extruder because the pressure is also high, so we can do our process efficiently by using grooved barrels, right? So therefore, in the industries you can see extruders with grooved barrels, right? In this diagram, again you can see the x-axis is die pressure, y-axis output, right? So you know what happened with the deep screws, right? In here I will explain. The both graphs are similar. Die pressure and the Q means the output. Die pressure for deep screws, it means the channel depth is high. Then pressure and output. So the output is high maximum when pressure is low. For the deep screws. Why is that? When we increase the pressure, automatically the pressure will also increase, and as a result of that, net flow will decrease. For the deep screws. For shallow screws, you can see with the pressure increasement, you can see the decreasement is very low. it's low than the deep screws. ඒ කියන්නේ screw එකේ flight depth එක වැඩි නම් ඔයගොල්ලෝ දන්නවා pressure එක වැඩිපුර generate වෙනවා. As a result of that pressure flow එක වැඩි වෙනවා. එතකොට net flow rate එක අඩු වෙනවා. ඒක නිසා pressure එක අඩු අවස්ථාවේ තමයි ඒකේ maximum output එක තියෙන්නේ. And when we increase the pressure, you can see the output will drastically decrease. But here, for the shallow screws, it means the flight height is low. Then again, the pressure is the output is higher in the at the stage of low pressure. But you can see its decreasement. It is lower than deeper screws, right? For shallow screws, when we increase the pressure, again the output will decrease, but decreasing rate is low, right? Decreasing rate is low. Okay, it is very important. Then there are again two parameters relevant to the Q. Q means the output. Output means number of kilograms per second, right? තත්පරයට කොච්චර කිලෝ වෙනවද කියන එක තමයි Q කියන්නේ, right? For low resistance, as an example, the very small die, right? Die shape is very small. Then with the pressure, output will increase, right? Output will increase. For high resistance, sorry, low resistance means large holes. High resistance means small holes. So resistance, therefore resistance is very high. As a result of this resistance, when we increase the pressure, again pressure flow will increase, right? So therefore, finally the output is low, right? So there are two major factors which will directly affect on the output of the extruders, the flight height and the resistance. Resistance means the shape of the die. It is basically depend on the shape of the die. When we increase the flight height with the pressure, the flow rate will, net flow rate will decrease, and with the small outputs, small die shapes, again with high pressure, the Q will decrease, right? So sometimes suppose you are going to develop two types of pasta, right? Might be spaghetti and noodles, right? Just an example, right? Spaghetti and noodles, you are going to use the same extruder, and for pasta you have to take a large die with large hole, right? So for noodles you need to get the very small die. So comment on the output of this extruder for 1 hour. මොකද වෙන්නේ? No idea. We are going to use the same extruder for noodles and pasta production. So can you comment on the output for same time, similar time period? No idea. එතකොට අපි අපේ කම්පැනි එකේ පැස්ටාත් හදනවා නූඩල්ස්ුත් හදනවා, right? Just for an example, right? ඒතර අද දවසේ අපි හදන්නේ පැස්ටා. අද දවසේ අපි පැය 10ක් එක්ස්ට්‍රූඩ් එක රන් කරනවා. හෙට දවසේ අපි හදන්නේ නූඩල්ස්. හෙටත් අපි පැය 10ක් එක්ස්ට්‍රූඩ් එක රන් කරනවා. මොන දවසේද වැඩිපුර ක්වොන්ටිටියක් ගන්න පුළුවන්? Yes, Prasadi?
ඒක අඩු දවසේ ෆ්ලෝ රේට් එක වැඩි සර්.
Yes. ඒතර නූඩල්ස් හදනකොට flow rate is low than the pasta, right? So therefore, we have to run the extruder for extra few hours, right? Because the pressure is high. Okay, thank you, and very good. So I hope that it's very clear. So we can move further. Then the single screw extruder classification. So we have discussed several classification methods. And we can classify single screw extruders based on the process and equipment parameters. Basically, dry and wet, screw shape, solid or segmented, degree of shear, low shear extruders, high shear extruders likewise, and temperature, low temperature extruders, high temperature. However, the main classification of a single screw extruders based on degree of shear and heat source, right? You know shear. Single screw extruder basic designs, increasing root diameter. You know what is the root diameter? Basic designs. There are several types of extruders based on their configurations. So we have some high root diameter extruders, and we can decrease the pitch but constant root diameter, constant root diameter and screw pitch, but decreasing barrel diameter, constant root diameter and constant pitch. P means screw pitch, but with restrictive pockets in constant diameter barrel combinations of formula. So we can develop several single screw extruders by changing these engineering parts, right? Root diameter, screw pitch, flight heights, number of flights. By changing these things, we can develop different types of extruder relevant to the each and every process. Here you can see some different configurations, the shapes of the screws and the flight changes, the flight designs, and you can see different screws in different shapes. Flight height also different, right? Number of flights also different, but here you can see the root diameter different. You can see different types of extruder screws are available. Here constant flight depth, single conical, double conical are there, and active conical likewise. Conical screws are also available. So different types of extruders are available. Here also you can see the pitch is constant but increase in the root diameter, right? Here you can see what happened to the root diameter, but pitch are same. But here again pitch is constant, root diameter is constant, but decrease in diameter. So you can see what happened to the barrel, right? Likewise, there are different designs we can use, different configurations based on our requirement. And the die shapes, there are also different die shapes, right? Based on the degree and shear, we can again classify the extruders. Cold forming extruders and high pressure forming extruders are available. But basically, we use cold forming extruders for the foods which is having 30 to 40% of moisture. It means moderate moisture. So this type of extruders, shear is low, smooth barrel surface, and deep flights are available. Deep flight means the output is comparatively low, low speed, not used for the thermoplastic extrusion. Pasta, cookies, pastry-like products we can develop by using cold forming extruders, right? We need not to have high pressure for pasta-like products, so therefore we are using cold forming extruders. When it comes to high pressure forming extruders, low shear, grooved barrel and compression screws are there. Pre-gelatinized flours and pellets, potato starch pellets like products we have to use. high pressure forming extruders. The pressure is very high, right? And low shear cooking extruders, again, we use low shear cooking extruders for meat-based product and pet products. And pasta also we can develop. For low shear means the shear is moderate, high compression screws are there, grooved barrels are there. The steam jacketed external heating method is usually involved in preparation of pasta-like product. You know, the cooking is there. So for that steam jacket, we use steam jacket for that purpose, and we can use it as a jacket. It as a jacket for the extrude screw. As a result of high temperature, protein denaturation, enzyme inactivation, pasteurization, realtization is there. Sometimes these are disadvantages and sometimes these things are advantages. So if it is a low shear cooking extruder, then you know the protein products, it's very difficult to use, right? Okay. In meat-based product, you know the protein, denatured proteins are there. Enzymes will also be denatured. So, but due to this high temperature, we can prevent this product for a long time because automatically pasteurization will also happen. Collet extruders means the shear is very high. Collet extruders, compression screw, multiple shallow flights are available. Brood barrel is there for low moisture foods. But the temperature you can see it's 150 to 175. So very high temperature is there for very low moisture foods. So therefore we can't use this type of collet extruders for pasta-like high moisture food products, right? The protein denaturation is there due to high temperature, enzyme inactivation, pasteurization, gelatinization, like activities are there. The very important thing here is due to this very high pressure, after dyeing, you can see an expansion. For example, TPT-like products, you can see expanded food products. So when it comes to expanded food products, the inner pressure is very, very high, right? So, you know, at the end of the dye, so the pressure difference is very high. As a result of that, such products will expand by absorbing atmospheric air, right? Example, TPT, right? So we have discussed 4 types of extruders, single screw extruders, cold forming, high pressure forming, low shear cooking and collet extruders. So now we have some food products available in the market. So you can take some extruded food products and decide whether it is a low shear extruder or collet extruder or what the type of extruder you can decide, right? I think it's you should have a very good understanding on these types of extruders. If it is expanded products, then you have to select a high pressure screw, the extruder with a high pressure. To get the high pressure, you can take a screw with high flights, the flight height with highest flight height. Likewise, then you can select the barrel. Sometimes you can develop your own extruder. You can manufacture it. You can fabricate it. So therefore, the engineering parts are important. So now I think you all can decide. You all can determine its configurations based on the product. So today you earn a lot about extruders. Now you are in a position to decide what types of extruders we have and which extruder we have to purchase, right? And there are some other specifications are available. Product density, screw diameter based on the shear. If it is a low shear, you can see the product moisture content is high, right? We can use this for high moisture products. If it is high shear, like collet type extruders, then we can't use high moisture raw materials. And product density, you can see we can't use the raw materials with high product density because the pressure is very high here, right? Likewise, screw diameters also you can see, and there are some details. So you can go through these details and check whether the differences and compare these extruders. Now we have learned 4 types of extruders today based on shear and everything. So you can compare the other factors too. So I will ask for your exams, you have to select the extruder, type of the extruder, moisture of the extruder. So actual plan you have to explain in your paper. So don't, you need not to remember. So I will give you an open book exam. So you can read all these slides and you can refer any book, you can refer internet. By using these details, you have to comment on my questions. So it's a case study type questions you will have. So please practice these things yourself at the end of this lecture, right? Then please, as I told you earlier, you can buy some food products and decide whether it is a high pressure or low pressure extruder. As an example, I will ask you questions. So do you have idea about the extruder type we select for soya meats? Soya meats? High pressure or low pressure? Chaturika Sadamali? To prepare soya meats, do we need to use a high pressure extruder or low pressure extruder? Chaturika, are you there? Can you hear me, Chaturika?
Yes, sir. Low pressure.
Low pressure? So meat take a past take right. Prabashi for spaghetti. For spaghetti, what type of extruder? Prabodhani? Are there Prabodhani?
Yes, sir. Low pressure. Low pressure extruder.
Huh?
Low pressure extruder can be used.
Very for a snack like you know, in summer portion like flour grain type flour manufacturing, we are using extruders. So do you have idea about the type of extruder? Vimukti? To produce summer portion?
I think mm, high pressure.
Moisture, you know, the moisture content is somewhat higher, right? Then you can't use high pressure.
Yes.
So please collect some samples from the market and check whether the extruder is high pressure or low pressure, and you can determine its flight depth, everything. Now you can determine, right? Please do this exercise for at least about 3-4 products. They are readily available in the market. You can get a soya meat, you can get a TPT like snack. So many products are available. Some types of bites are available. So please do this exercise, and some breakfast cereals and breakfast product like cornflakes. are available. Some pet foods are available. So please do this exercise yourself. Okay. Now we are going to calculate the solid flow rate of the single screw extruders. So that's why I ask you to come up with your calculators. So this is the equation. I'm not going to explain one by one. You can see solid flow rate. Flow rate, as I told you earlier, kilograms per second. තත්පරයකට කොච්චර kilograms එනවද කියලා. Then solid bed density is there. It means the density of the batter or density of the dough mixture. As an example, you know, we prepare a dough for string hopper manufacturing. You can imagine the dough mixture. So likewise, we are using a type of dough mixture in extrusion. So its density is there. H means channel height. You know what is the channel height? You know what is the W, channel width, and number of parallel flights, N, right? It should be simple N. And barrel velocity is there, solid conveying angle, and screw helix angle. All these things you know, right? So now you know the equation, it's there. So I will give you an example. So you have to do this example and tell me the answer, right? A low shear extruder using pasta manufacturing company has designed as follows: channel height, channel width, number of parallel flights, solid conveying angle, everything is there. Also, they use water and wheat flour as their major raw materials, and the average dough density as they have calculated as 1260 kilograms per gram meter. So calculate the net products weight of the first batch. Calculate the net products weight of the first batch, right? Produced within 9 to 10 a.m. a day, while the barrel velocity is maintained at 10. So you know, you have to calculate the MS, and the density is there, 1260 kilograms per cubic meter, and the flights, everything is there. Equation is there. You know how to calculate the sign values. So now it's your time. Please try to solve the question example using the following equation, right? Equation is there, question is there. You have calculators. Please do this example. Please read the question carefully. Okay, start.